Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box we have some mystery math and your challenge is to figure out what that is. You can use the link in the description, try it out, and when you get an idea come on back and see if we get the same thing. Alright, let's put in a 0. So 0 gives us 0, how about 1? Okay, so 1 gives us something close to 1, looks like a non-repeating decimal, so maybe a square root function, maybe trigonometry. Let's look at 2. So we've gone up and then down, so this is starting to look like trig. Let's put a few more points in there, put in a 3, and back up again. Let's try an approximation for pi, so 3.14. And we're basically at 0 again there. So, this is looking interesting to me. Let me try some negative values. And maybe a negative, well, let's do a negative 1.5, so something close to pi over 2. And that's pretty close to 0 again. Let's try a negative 2. Yeah, and I'm going to do a negative 3.14, approximate negative pi here. Okay, so I think you can start to see from the dots here that we've got that waveform, and so it's either sine or cosine, and I'm thinking sine because at 0, it's 0. Remember, these sine and cosine functions, we think about putting an angle in. So an angle of 0 would be right there, and where it touches the unit circle, the coordinates give us our sine and our cosine. This is the point 1, 0, and 1 is the cosine, 0 is the sine. So it's always the y coordinate that gives you the sine value. And then up at pi over 2 here, that's where we have the point 0, 1. And so our sine should be at its biggest there. If we look at pi over 2, well, we didn't really put that in. Let's put in an approximation for pi over 2. We're actually very close to 0. So what is going on here? What should be happening, if this is just the sine of x, it should start at 0, which it does. We start at 0, and it should go up and up and up until we get to pi over 2 and then start to go down. But it looks like it goes up and then very quickly goes down again, and when we get to pi over 2, we're back at 0 already. That's what happens on this interval from 0 to pi over here. So over on the other side of the circle we have pi, and that is the point -1, 0, and sine is back to 0. But it looks like what's happening is it's going through that whole thing in half the time, in half the space. So by the time we get to pi over 2, we've already gone up and then down again to 0, and then again we're going down and back up to 0 by the time we get to pi. This whole cycle here, this whole period of the function is happening in half the time. So usually it takes going all the way to 2 pi to get through a full cycle, but we've done it by just the distance from 0 to pi. So what does that mean for our function? Well, you can achieve that. You can sort of squish this thing or increase the frequency of the function by using a multiplier inside the parentheses. So this would be the sine of, and since we're actually doubling the frequency here, it would be the sine of 2x. But let's just think about this and make sure it works. When you put in 0, 2 times 0 is still 0, so the sine of 0 is still 0. That makes sense. If we think about pi over 4, so pi over 4 times 2 is going to be pi over 2. And that's why at pi over 4, we're actually, right around here, we're actually up to the highest point we get to in this function. So it's like it's pi over 2. And then if we go all the way to pi over 2, well, we multiply pi over 2 times 2, that's pi. And then we're going to get these values for pi. The sine of pi is 0. And that's why we get to 0 here around pi over 2. So I think we've got this. I think this is the sine of 2x. Let's go ahead and take a look at that. Yeah, this is the sine of 2x, and we can graph that. I think we can graph it. There it goes. Yeah, so there is the sine function, except it's just squished. Normally, this would go all the way up to here. Let's do this. And actually, let's do this in a different color. It would go up all the way to here and then start going down again to here and so forth. So it's just squished it and doubled the frequency. Well, how did that go for you? Did you get that it was trig? Did you figure out what this equation was? I think this was a tricky one. Let me know. Thanks, everybody.